Alright, time for another DraftPhysics.com video presentation. Here I am. So the Huygens optics guy has posted his part 2, and I guess he's going to have a part 3 on these photons, and he's mostly talking about what I would say is sort of a obscure or not entirely related subject of how you make light coherent. How photons end up arriving at a location, let's say, in some sort of manner that makes photons more likely to arrive. Taking chaos, so sort of an anti-entropy argument that somehow photons created, like say, on the sun's surface, end up at a distance, arriving in some more coherent manner or consistent manner. And that's true in, again, water waves. So in mediums that are elastic, so you could argue that water molecules are very elastic in the sense that they can take lots of different vibrations in water, and because they will communicate those vibrations with each other, they'll add and subtract, and then they'll end up creating a net product in terms of the energy. So the energy is moving in a direction, it's moving at different frequencies, and those frequencies in a medium will end up being combined. And you end up with a product, a sum of the energy that ends up being more coherent. So it's like it sort of is an anti-entropy argument. But it's made out of a fact that you have a medium that's elastic. So again, if you think space is an elastic medium, then okay. But if you're like me and you don't buy that, then you have to come up with a different explanation for why things happen. And so whatever, that's what his video is about, okay, primarily. But he has thrown in this piece that is, in a sense, a concession to my argument. Now, I don't know whether I provoked this concession to my argument or not. I mean, it's a couple weeks later, so, maybe he did some research and he has realized that maybe some of the things he's believed or said about the famous Young double-slit experiment were, in fact, not true. And that the truth is something else. And that all of this, well, he's not conceding these points, that the whole story, the whole narrative, has been written in a context that doesn't really exist. The truth is, trees don't talk, monkeys don't fly, horses don't change color, or the tin men aren't alive and looking for their hearts. This isn't Oz, and these fables written as if it was Oz, these stories, are not credible. So anyway, I'm going to play this part just because, damn, everybody should hear him say these words and recognize, okay, maybe we shouldn't keep lying, okay, about the history, because it is just a false and fake narrative. This is how they support their theory, is with this fake version of the history. And he ought to do the same thing for the kinetic energy formula, But anyway, so let's play it.
It's interesting to note that when Thomas Young wrote his paper about the theory of light and colors in 1801, he did of course not have a laser or any really bright light sources available other than the sun, and so Young was more or less forced to use sunlight for his experiment.
And so was Newton, so let's understand that, in context, Newton had already done these experiments. I mean, he had done the small aperture, and he had done the impediment. And the argument is that's all the double slit is made out of, is an impediment and an aperture. So you could argue that, this was already knowledge. And, that's probably enough. I'm trying to think whether it was Hooke who did the single photon experiments that I think also were previous to Young's experiments.
I've read on the internet he used a mirror to direct the sunlight through a tiny pinhole into a darkened room to create a bright beam of light. And with the knowledge you have just acquired about the area of coherence of the sun, I think it should be fairly obvious.
Okay, so yes, he prefaced this, most of this video is about this coherence argument, which again I would argue doesn't mean much. But we're just basically saying that what you're trying to do is create a beam of light that doesn't have irregularities in terms of its source. It's all they're all at the same place in terms of the frequencies of the light. It's all in phase light.
Obvious to you what the function of the pinhole is. It's intended to make all the light entering the room spatially coherent.
Right, and we know it can't really do that just because, well, frankly, it's a surface again, and the surface is going to bend light both directions, bend light in and bend light out. So yeah, it's going to basically become a little less coherent because you've created sources. So it all depends on how you understand the concept of light. So if you understand the light to be a bunch of light quanta, as Einstein would have put it, then yes, you're going to create some chaos to narrow the beam, to take a piece of the light. You're inevitably going to create some chaos in the light, in spite of the fact that you're attempting to extract chaos.
When I tried to confirm that this is how he actually did it in the original paper, I couldn't find any reference to a mirror or an aperture in the window.
So yes, it's a truth that it's not very well documented. So Veritasium couldn't find even how to build the device. So he just used a cardboard box and this and that. So they just pieced this stuff together. And it's just, it's so distant from being the solid truth that they project it to be.
Or to a double slit for that matter. Yes, that's correct. Thomas Young's famous double slit experiment actually did not involve a double slit configuration.
Right, so this is what I also read, was that what he basically did, he has a beam of light and he put a card in front of it. So he has two surfaces. So he put an impediment, a thin impediment. And so some people will describe a single impediment as the two-slit experiment, but somehow there's two waves, two choices, left and right. Therefore, it's just like the two-slit experiment. And I would, of course, argue that what they're missing is that if you really analyze the math and the vectors, you need those two outside surfaces. Without those surfaces, it's not the two-slit experiment, and you're not going to get the double slit pattern. You're not going to get the envelope pattern on top of the interference pattern, if you want to call them those two different things.
Configuration. Instead, he placed a thin card in the beam.
So what he did do is he placed this image, and this is a famous image used to, obviously Young didn't take a picture of what he saw. So I would argue that this is another kind of a fakery. This is a double slit pattern. All right, it does have the break in the appropriate locations, and you can see that these nodes is basically, there was 3 nodes here, there's 5 lumps here, could be 7, could be 9, could be 11, could be 13, could be 15, could be any one of those odd numbers in the middle, depending on the width of the slits. The wider the furthest surfaces are, the higher number of bars you get in that envelope.
Split it in half, which caused the diffraction pattern. And this is how he could observe the separation of light into different colors. Even a few years later
But his mission wasn't to separate into different colors, and the separation, because it's such a narrow part of the spectrum he's using, it never fully separated. So what he saw was, red edges on the outside and blue on the inside.
In his 1804 paper on the same subject, there is no reference to a double slit configuration anywhere. However, 6 years after the original experiment, Young published 2 books that contained a large collection of lectures, and in volume 1 he did actually mention a configuration resembling a double slit.
Right, and again, the slits are so narrow that there is no double slit pattern. That is, it doesn't go any further than 5 bars, and that doesn't tell you much. It's not really about the double slit then. So that would be my argument, is you're really just showing a version of a single slit because you've turned what should be a 4-source experiment into a 2-source experiment. and his wave theory math doesn't get the right answer in that circumstance. If you use the dimensions of the opening, that is, if you use as your distance measurement the center of the slit openings, you won't accurately predict the location of the bars.
The reason why I think this is interesting is because it illustrates how we communicate about science.
Yeah, it illustrates that there's no real communication in the concept of any debate or any argument. There's no theater for the debate. There's no theater for the conversation. It's all just a group of controllers, and the controllers just tell everybody else what the truth is going to be. It's like the writing of the Bible. Okay, it's all written by a bunch of elitists, and they tell everybody else what the truth is. And this fable has got the same kind of corrupt history, in that there's no open forum to debate any of these axioms, and they're just established as a fact. They proved its waves when they never proved any such thing. It's all that kind of crap, frankly. It's as bad as a religion. There's no real scrutiny, and clearly every time you try to apply any scrutiny, all you get is aggressive negative feedback. Nobody wants to see the argument because they just want their religion to be the truth. I mean, we just live in this fascist environment where people just don't care about integrity and the truth.
We don't necessarily communicate facts. Most of the time we communicate metaphors.
No, most of the time you communicate fables and your own personal subjective biases. That's all that gets communicated. And again, what's the point of the communication if it isn't tested? They're just project a truth, and they avoid any scrutiny, any testing.
That represent the essence of an experiment and not necessarily the details of the actual configuration.
Right. So again, and this is classic. Again, I can play literally hundreds of people saying Thomas Young proved light is a wave, when he didn't do that. His drawings don't work. They don't really describe the complex double slit pattern. All they really do is create a fake single slit because of the very fact that he eliminates point sources. And again, this, which I'll show later in this video, this guy's essentially in some ways doing the same thing, but I'll show you there's a huge flaw in his reasoning.
So somewhere in history somebody decided to name it Thomas Young's double slit experiment, and this then became synonymous with the phenomenon observed. Now,
it came synonymous with, we've proven it's a wave. That's what it's synonymous with. Somehow we needed some facts to throw at Einstein and anyone who thought the universe might be made out of corpuscles of energy, and Newton. That somehow that's wrong and it's not the truth, even though they have this photoelectric effect and they have these other experiments that indicate it is the truth. I mean, they have laser beams.
Don't get me wrong, there is nothing like a good metaphor to explain difficult concepts to an audience of non-experts.
Yes, I think analogy would be the better thing, but look how dangerous it is. You're showing the very danger. You're saying light is something like waves in water. It's nothing like it, really. In single slits, it doesn't create anything like the same pattern, all right? Because water doesn't create two waves. In the double slit, it doesn't create the double slit pattern, the two patterns superimposed on each other. So, I mean, it's not a good metaphor. It has a tiny superficial similarity, and yet you use it as an analogy, okay? And metaphors are even worse, because metaphors, you just start getting into talking fish, and there's no point in going there.
However, extending the use of metaphors beyond what they're intended for.
So again, what they're intended for, we don't have any choice except to, we have a word like fast, and you'll say, well, fast like a rabbit or fast like a speeding bullet. Okay, you're going to compare it to something else that's fast and say, look, it's like a speeding bullet. So we don't have much choice. We have to define things with previous definitions. All the words have a definition. A definition is a description of something, and so then we have to make a comparison to that something. So round things we compare to round things. Square things we compare to square things. We have to do that. But the problem is when you sit there and say, well, it has a tiny similarity. You know, platypuses lay eggs and they have a bill, therefore they're ducks. That's the problem.
And become pretty confusing. Take the double slit experiment for single electrons instead of photons.
Right, so I mean I've pointed out before, yes, the true experiment is so distant from what they describe it as. They illustrate it one way. The actual experiment has to do with crystals and this and that, and they do the same thing with their entanglement experiments. They say it's this, this, and this, and then you find out what they actually do, and it's nothing like it. It doesn't have anything to do with slits and, you know, which ways.
Here are a few examples of how that experiment is depicted. See if you can spot the confusing aspect.
Now, the point is it's always depicted as if the electrons are being shot at slits. And yes, there is actually an experiment where they do that. When they use a layer of gold, and the gold wasn't thick enough, and the photons were going through the gold, and blah blah blah. So you can find out lots of. But the problem is it's not the same experiment because electrons are charged, and there's nothing you can shoot them at that's not charged itself. So of course they're going to behave differently than photons because they're charged. You can't. I mean, it's so unrealistic to think whatever you're going to get as a pattern is going to be for the same reason as photons, because photons aren't doing the same thing electrons are doing.
It's not the cougar here, which might...
I think that's just a cat. It's supposed to, I think, represent Schrodinger's cat and throwing cats through the slit. You know, that kind of art. It's supposed to represent the metaphor of, well, what if you threw cats through two slits? You know, would they do the same thing?
Very well be a metaphor for something else too. Who knows? No, the confusing aspect is that all these visuals show narrow slits with a very substantial distance between them, which makes the experiment intrinsically mysterious. Because,
well, the point I would argue is that if we really understood the experiment, just said, what's the obvious feature of the experiment? Oh, surfaces. That's the obvious feature. It's the obvious feature to Newton in the sense that what are you doing with an aperture? You're making the aperture smaller. The smaller you make the aperture, the more fringes you get. Why? Well, because it's more likely the photons are going to be, near a surface. There's less photons not going near the surface.
How can a particle small enough to pass through a narrow slit pass through two widely spaced slits?
Right, and that whole premise, that whole axiom that's what's actually happening, that's every single photon goes through both slits to create the pattern. That's the canard.
At the same time. However, if we refer to the original experiment performed at Hitachi, the interference was actually created by using an electron biprism. And this device basically consists of an extreme...
And it's not even a prism, so let's understand, it's not like it's an optical prism. It's a prism made out of charge. Yes, so you're bending the electrons, you're aiming the electrons. It's the very opposite of what the double slit is supposed to be, where you're not supposed to be aiming photons, and you're supposed to be getting this coherent result with unaimed photons. And the electron experiment, it's all about aiming the electrons.
Thin charged wire with a thickness much smaller than a micron. So when you look at this configuration, the interference effect suddenly becomes much less mysterious, because it's basically about how the electron interacts with an object small enough as to demonstrate that the electron has wave properties.
Well, and it's not about an object, it's about a charge object. They put a positive charge on it to bend the electrons. I mean, seriously, it's not about hitting the object, it's about being bent around it.
And so the metaphor of the double slit and the way it's presented doesn't necessarily help people understand.
Okay, it's not a metaphor, it's a direct, overt statement that they make. So it's not even that they're using a metaphor. They're overtly stating this is what happened in the experiment, and it's fundamentally not true. So frankly, to say they're using it because they're making some kind of legitimate comparison, they're not making a comparison. They're overtly saying this is what the experiment is and this is what came out. Just like in the Young experiment, they're saying the Young experiment is the double slit pattern, when that's not the pattern Young is describing. He's describing a single slit pattern.
If anything, it just adds to the confusion.
There isn't any confusion. You're all arrogant, obnoxious declarers of the facts. You're telling me what the truth is. You're not sitting there suggesting a truth and saying, well, there's numerous ways this could be interpreted. We, of course, won't listen to any of them or describe any of them to you. We'll just obnoxiously tell you what the truth is.
Ah, well. All of this doesn't change the fact that actual double slits do a good job in demonstrating the effect that Thomas Young observed.
Okay, so that's the lie. So again, you're just reinforcing a lie. That's not what Thomas Young observed. He didn't observe the double slit pattern. He didn't in any way explain the double maxima in the center, and he didn't explain the fact that the pattern is broken and then restarts and then breaks and then restarts, because he didn't see that. So, this is just, why are you sitting there saying it's a perfectly fine that we have this fake story about a fake analysis and the math itself doesn't even work? It doesn't describe what the pattern you'll actually see is. Two waves can't make the double slit pattern. It's impossible to make it out of two vectors. Two vectors won't turn the pattern on and off. It won't create the envelope. And it also, your analysis won't create the double maxima in the center.
So let's do a true double slit experiment that illustrates the effect of...
Alright, so he says this is a true experiment. He had done this experiment previously already. Alright, months ago. So he's using it for this coherency purpose, for which I don't understand. So he's doing the experiment with a microscope. So it's not exactly anything like the double slit experiment in the sense he's not projecting an image. So he's not going to see the photons as they're projected on a surface. He's going to look right into the slits themselves with compound lenses. And then say what he's going to see is the actual photon event, when I would argue, no, what you're going to see is what happens to lenses, okay, in microscopes.
Spatial coherence in light. And for this demonstration, we'll use white light. So here are two slits.
So there's no good reason to use white light, just because with microscopes, we already know that this can happen. If anybody's used a microscope, right, you're looking at an object and there's lots of distortions that are color distortions, in the sense that the fluids around a little microbe start turning blue. They end up with a blue fringe around them, because the light's being separated. The light isn't being focused. The different colors of light aren't being consistently focused, and so you're seeing some colors in focus and some colors out of focus.
Etched in a layer of chromium on a glass slide, and we are looking at them under a microscope.
Alright, so again we have an illustration that can't really show what you're actually, in the actual dimensions. Obviously you're not looking through a gigantically long eyepiece, so it's not exactly the truth. But anyway, I'll get to the point. Let him just say what he's going to say.
They're actually quite small, about 300 microns long and 5...
Alright, so they're really, really tiny slits, okay? And the argument would be, when you make slits this small, this is again the Young problem. There can't be any possibility of creating positive and negative, constructive or destructive effects, because you don't have enough, there won't be enough little bars. You're just going to end up with 3 bars or something. So you're just going to spread the light way too much, because the distances are so close, you're creating essentially the same point source. So this is, again, the argument would be is this distance, this 5 distance is so close that you can't create, for any frequency of light, places where there's constructive and destructive interference. You just don't have any locations where that's possible because the two surfaces are too close together.
Microns wide. Why so small? Well, because we really want to bring out the colors and the interference here in a lot of detail.
All right, so it's not going to be colors in detail, and it's not going to be adding value. So this is, he says this is the real double slit. This isn't the real way to do the experiment, frankly. It just, talk about adding confusion. This just adds confusion. Microscopes have they do a lot of things. Okay, there's like at least 3 lenses in this microscope, at least 3, maybe many more. And some of them are coated, so they're creating thin film phenomenon also. And so this is way more complicated than what he's implying.
Place a link to another video in the description about how you can record this type of images.
Right, so this isn't, it's just a microscope with a camera, blah, blah, blah. He's going to look at these 2 slits after he reflects it off of a prism, which again, whatever.
We'll start out by looking at how
Alright, no, that's the light going through the slits.
the light through the slits develop when the area of coherence is much smaller than the dimensions of the current double slit.
See, this coherence argument is really about where, if you understand the photon isn't a wave, and it isn't some big monstrous thing, it's made out of light quanta, as Einstein would put it, then the point would be is that you can be getting a piece of quanta can be at any location. So it could be coming from here, it could be coming from here, it could be coming from there, it could be coming from there. That the little bits can be thrown from very different locations. And then they can end up moving in any direction as they're coming out. So they can be any location. It's like my image in the real world is very different than what you see because you're seeing me through a little aperture that's guaranteeing the angles that the photons are possibly landing from. But realistically, if you weren't looking through a little lens, I could send photons straight across. But you can't see them because your eye isn't that big. So how to explain that? So if we didn't have an eye, what you would see, you can't really focus, and photons could land anywhere on me, made from a bit coming from over here on the screen, or another bit could be way over here, and another bit could be way over here. So it won't create an image. It'll just create a photon. But you won't be able to trace the photon and say, oh, the photon came from here and is this color. The photon is made of a composite and it won't create any image. A composite of locations. So what an aperture does is force it to really, essentially, the energy has to come from a place.
Configuration. Basically, this can be achieved by placing a white LED very near to the slits. If we now move away from the slits,
so it seems you got rid of the mirror for whatever reason, or the prism.
Observe how the light passing the slits is diffracted and how.
All right. So if you've ever used a microscope, look, he's the guy he's an expert on lenses. Okay, he's done a lot of research and a lot of work and a lot of experiments with lenses. So I have no deep knowledge about all the effects of aberration and change that lenses can create. All I do know, though, is I have used a microscope, and I know the focal length of a microscope is insanely small. I mean, that's the whole point of the compound lenses. And so, you can't focus. Like, you wouldn't be able to see this word. I move this a tiny bit forward, you can't see it. I move it a tiny bit backwards, you can't see it. You wouldn't be able to read anything, okay, unless it's in this one plane, one thin place. All right, so that's what microscopes do. So as soon as you have something that you see the image, as soon as you start moving, you're not going to see any image anymore. Okay, that's gone. What you saw is gone, and what you're now seeing, okay, is a much different image, because it's not that one plane here anymore. It's some other plane where there is nothing. There's nothing to focus on. There's nothing there. There's nothing in that plane, so you can't see anything.
This results in two blurry blobs that merge without any noticeable interference. And this is because the light does not contain any phase relationships on points in the slit area. So this is not particularly fascinating, right?
Right, so he just looks at two and then puts it out of focus and basically says, look, there's nothing there.
Now let's replace the close by positioned LED with a light source that produces spatially coherent light.
All right, so he's getting rid of the LED, which is creating light from different locations, different little path lengths. It's a little more chaotic, and he's trying to replace it with a light source where, all of the photons are essentially moving in sequence with each other. So there's none coming at different angles.
This means that the area of coherence is much larger than the total area of the two slits. And so in this case, there is a fixed phase relationship for every wavelength at every point on the slits. And look what happens now if we do the same experiment.
And so all this is I would argue, these are artifacts created by the compound lenses in the microscope. If we was to project this image, that is, it was take what was coming through those slits and put it on a screen, and then view the screen, or even a transparency, and let the image hit the transparency, a diffraction gradient or something, and then look from behind at what's hitting the screen, and then to focus on what's hitting the screen, he's not going to see any of this stuff. Because these are all artifacts created by the fact that the lens is treating the different colors of light differently. They all have a different focal length.
Once the light from the two beams starts to overlap, we observe this fascinating pattern of colored lines developing.
So it's a pattern, okay, you want to see, it's fascinating to you. It obviously doesn't have any real coherency to it. It's just, it doesn't look anything like a slit experiment. The bars aren't all even. It's a mess. It's a mess of different colors, obviously, at different focal lengths. And what you're really doing is just focusing on them, not focusing, out of focus, in focus, out of focus, in focus. You're just changing which ones you see where.
Because of the different wavelengths going in and out of phase.
And some of them will end up being, just like any resonant frequency phenomenon. You can have two, the blue light can be this close together, and it cannot match the red, okay? But at one spot, it will, the red and the blue will overlap. And then it won't overlap for a while, and then it's going to overlap again. And then it won't overlap for a while, and then it overlaps again. So there's places, as you move in and out, where you get overlaps. And that's all this is.
What we observe in this pattern is
So I would argue this is what you're observing is really just mirror images of the surfaces.
actually temporal decay.
Okay, so temporal this, and so I'll play a little bit more of this, and I'll just draw what, why I say this isn't what he's saying it is. He's saying that these bars are being created by interference. I'm going to argue that's impossible because these bars are way too close to each other. There's way too many of them, and there's no way you could create them with the interference theory. The interference theory doesn't allow it because there aren't any vectors that make it possible. There's no math that can make it happen because you can't have interference without having wavelength, path length differences. And the only place you're having those wavelength, path length differences is in your compound lenses. This doesn't show up. Your lenses are creating this. This isn't what the slits are creating. This is what your lens is creating.
Coherence. In the center of the pattern, all the wavelengths are in phase with each other because the distance to the two slits is equal for every point.
Right, so he just said the distance is equal to the two slits. The distance from the two slits is insanely small, and on top of that, there isn't any dimensional difference. There's no triangles. There's not enough base in the triangle for you to possibly create path length differences. except in your lens. The lens is moving the light this way and this way, right? And it's doing focuses. The lights are crisscrossing. It's doing lots of inverting the image and turning the image upside down again. It's doing lots of that crap.
That line. But as we move away from the center, every wavelength has its own interference periodicity. And so the phase differences between the light originating from two different slits will be different for every wavelength.
Right. But that doesn't have anything to do with this because, of course, the different, again, he's using different colors. It just confuses the issue. So I don't think there's anything else in here you need to hear.
So this is the reason why you need spatial coherence to do a proper double slit experiment.
Okay, so again, that's just, he's calling it a proper double slit, and it's preposterously improper because the big slit experiment shows you quite clearly the pattern, and it's a consistent, mathematically rational pattern. There's nothing, you can't do the math for what he's showing there. All right, so I will draw a little bit to explain what I can explain of this. From, again, my less than expertise. What the hell? How can that be that? Oh, that's this thing. Okay, that's better. All right, so it's a microscope. Okay, so you got two little slits. All right, and you're basically letting the light come through those two slits. Now, the simple argument is the mathematics understands that you have to have this distance, and the distance decides these triangles. All right, so you're going to go to a location, and what you have to have is a path length. You have to have wavelengths of difference. Well, you can understand if this base of this triangle is really tiny, and it's really tiny in the case of his experiment. Frankly, the first case is the slits are 0.35, whatever he called them, and the distance between them is maybe 5 units of that distance. It's not nearly enough, okay, for you to create anything more than, say, some kind of single slit pattern like that. All right, you can't, there's no wavelength of difference possibility here, or 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 here, because this base is too small. These two lines can never be a wavelength of difference because the base of the triangle's too small. It can't happen. It's this argument, right? If the one opening, the surface is here and the other surface is here, this is the distance in the mathematics. And the problem is there's not a wavelength of difference here. There can't be a wavelength of difference here. Okay, it's not possible. So no matter where I put the dot, I can't make a spot where there's a wavelength of difference because there's not one here. If there's not one here, there can't be one anywhere in space. So no matter how long I make these lines, no matter how long I make the L, I can't make this line more than this tiny distance longer than this line. And no matter where this triangle goes, I can never fix that. So my argument is he's showing it and say this is the real double slit, but it denies the whole point of interference, which is the whole point of interference is having a phase difference, and he doesn't have any dimensionality to create the phase difference. There can't be a phase difference because he has he has no mathematics to defend a phase difference. So, and he certainly couldn't have, as the experiment he's showing, he's got a whole bunch of lines, and they're in a space, okay, an angular space, because it's a microscope, this is a tiny amount of space. He's not looking at 180 degrees of space. He's looking at a tiny, 5 degrees of space. And so he's saying there's 20 bars inside that 5 degrees. Well, then there have to be hundreds of bars in the whole field of view, and that would mean you'd have to have hundreds of wavelengths of difference. He doesn't have 100 wavelengths of difference. He doesn't have 50 wavelengths of difference. He doesn't have, he doesn't have it. So he can't make all these bars. And realistically, just think about what he's saying. As I zoom out and I change the focus, I see the bars. Well, why wouldn't I see them when I'm focused on the slits? There's no reason when I'm focused on the slits that I shouldn't see whatever interference they're creating. I should already see it. There's no reason I shouldn't be able to see, you know, if there's a slit and I'm going to look at it with a microscope. There's no reason I shouldn't be able to see anything that's coming out that's making slits, that's making on-off pattern. I should see the on-off pattern when I'm in focus. I shouldn't have to go out of focus to see the bars. So it's really not the real double slit experiment. The real double slit experiment, as I have pointed out over and over, let's just draw it real quick. This is the real pattern, and this is what your wave theory has to explain. Your two-wave theory has to explain this pattern. You can't keep lying about what its obligations are. Okay, it has to explain this double, and it has to explain these absences of photons are weak, very weak. You know, it's barely visible photon. That's what it has to explain. And two-wave theory coming through two slits, okay, can't do that. Okay, it doesn't do that. You need four sources to explain, because the simple explanation is when two of the sources hit a location, very weak photon. When four sources contribute a quanta of light, then you have twice or four times, actually it's 4 times the likelihood of making a photon. So if I change from just 2 sources to 4 sources, I quadruple my likelihood of being in phase in that location. So yes, these locations, all 4 sources are in phase. The widest 2 and the narrowest 2, okay, are in phase. You have lots of little bits hitting, more likelihood of being in phase. And when they're in these locations where they're not in phase, yes, these 2 are in phase. These 2 surfaces might be in phase here, but the other 2 aren't. So no photon. And that's the explanation. The smallest distance between 2 surfaces is creating the envelope, and the widest distance between 2 surfaces is creating the small bars. And that's the real explanation of the double slit. And they won't talk about it, they won't think about it, they won't acknowledge that there are viable counter theories to their wave thingy, their wavel beam, laser wavel beam, or whatever. I don't even, again, they're whatever this snaking electromagnetical blah 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 blah, whatever the hell that is. They're anti-Einsteinian explanation. All right, so probably enough of a video. So I'd like to say I don't got anything against these people, but I mean, they're preaching a religion, and they really don't want anybody else to point out how, well, you really don't have any evidence for that. That virgin birth thing, I heard there was like 21 virgin births. That's not some sort of spectacular thing, you know. It's not like that never happened before. You know, just pointing out flaws in your story, okay? It's okay to rape women as long as you marry them afterwards. I mean, that's, you know, that's the ethics of your Christianity, okay? So I could point out just the same kind of flaws in your theory. Okay, you say it's a wave. Well, why doesn't a single slit in water create an interference pattern if it's just like water? Where the 2 waves come from that are interfering with each other. Yeah, right. Okay, so enough. Yeah, that's enough. All right. So till the next time and such, I'll post this on YouTube because it is a video directed at somebody who has produced a YouTube video and such. There's got to be some willingness to have a conversation, a give and take, a back and forth, pointing out what experiments actually show what. Because the rest is just hype. The Young double-slit experiment does not prove light's a wave. It doesn't do it. Oh, I guess I could appropriately, gracefully exit. So we'll try that. And just slide stuff out, slide out, and I'll just disappear. There. So this has been a DraftPhysics.com, DraftScience on YouTube, or DebatePhysics.com video presentation and such.